Welcome to Mastering Solutions. In this question, let's draw a picture because this question, a lot of the difficulty comes in just setting it up correctly. The actual question as far as the math is not very difficult, but it can be hard to set it up right. And so here is our normal. And they tell us that the sun is 60 degrees above the horizon. So this light here is coming in and it is 60 degrees above the horizon. And then it's going from an N of 1 in the air into the water, which is an N of 1.33, of course. So it's going to get refracted. It'll refract towards the normal since we're going from a low to a high index of refraction. And they tell us that we have a stick in the bottom down here. And so this is the challenge in setting it up. If we set the stick so that it's just barely catching the edge of this light ray, you'll see why that's important here in a second. They tell us that the stick is 10 centimeters tall, 10 centimeters. And we could put that into standard units. So let's move it 1, 2. So we have 0.1, or you could also say 10 times 10 to the negative 2 meters. These are all saying the same thing. So the reason we set this right here, because if we set it so the sun is just catching this, you can see that, of course, we just created a right triangle right here. And so if we redraw this triangle, this is the height of the stick, which we said was the 10 times 10 to the negative 2 meters. And then this, we don't know what this is here, but this is going to be the length of the shadow. So we'll say Y for shadow. We need to know what this angle is right here. And if you see, this is going to be the exact same angle if we use Snell's law. So that'll be theta 2. And if we write down the Snell's law, we know it's N1 sine theta 1 is equal to N2 sine theta 2. But one tricky thing that they did in this question is they told us the sun is 60 degrees above the horizon. That doesn't tell us this angle right here though. And remember, it's always from the normal out to the ray. This is where a lot of students will get messed up. And so we know this is a right angle here. And so we have 60. So this is going to be 30 degrees for this angle to complete the 90-degree angle. So our angle, our theta 1 is going to be 30 degrees. So now we want to solve for theta 2. So let's isolate that. We'll divide both sides by N2. So sine of theta 2 is equal to N1 sine theta 1 over N2. In this question, you could simplify this since it's 1. I'll leave it right here just so we see the math, but plugging into our calculator, we could leave it out if we wanted. And so now we need to isolate this. We'll take the inverse sine of both sides. So theta 2 is equal to the inverse sine times N1 sine theta 1 over N2. All right, so now let's plug all our numbers into this. So theta 2 is going to be equal to N of 1, we said, times sine of the angle theta 1, and that is 30 degrees like we talked about. Now that's going to be over the N2, which in this case is water, so 1.33. And when we go to our calculator, as always, make sure it's in degree mode since we want a degree. And we're going to have inverse sine, and then we have 1 times sine of 30, and that's divided by 1.33. So the angle is 22.1 degrees. And so that is this angle right here. And now we can use this and we can use SOHCAHTOA to figure out this length right here, which is the length of the shadow. And so to do that, we want the opposite and we have the adjacent. So we'll use tangent, and that's tangent of the angle is equal to opposite over adjacent. We want the opposite, so we'll multiply both sides by A. So opposite is equal to A times the tangent of theta. So plugging in our numbers here, we're going to have, and I'll say this is Y just so we can see that that's what it is. So now Y is equal to the adjacent, which we said was 10 times 10 to the negative 2 meters, times the tangent of the angle, which we found is 22.1 degrees. So we have 10 times 10 to the negative 2 times the tangent of 22.1. And that gives us 0.04. So we go 1, 2, and we could round this to 4.1. So the length of the shadow is going to be 4.1, and we move the decimal place 2, so 10 to the negative 2 meters, or 4.1 centimeters. So this is your answer for how long the shadow is, and we found that using Snell's law and some trigonometry.